Good morning, everyone. Welcome back again. Yeah. Let me know in the comment section. Am I clearly audible and visible? Yeah, I think I'm visible. Is the audio clear to you? You can let me know in the comment section. I think yes. Yeah, good morning. Right. Good morning, Purnima. Good morning, Alekia. Yeah. Right. So, dear students, we started our bridge course yesterday targeting the NEET 2026. And I hope you have enjoyed the yesterday's session in which we have studied the Galileo's formula. And in every session of this bridge course, I am not only going to guide you for the physics topics or physics chapters, but also we will try to understand the better methodologies to deal with the crucial problems. And basically, we are trying to learn how to actually learn physics. All right. Every subject has a different way of learning. The way you prepare yourself for the biology exam, the same way you don't have your mindset to prepare for the chemistry exam. And same is applicable for our favorite subject. Yes, that is physics. All right. So in every subject needs a different kind of orientation of mind, how to prepare. So on everyday basis, I'm going to come up with interesting topics which will directly contribute hopefully in the NEET 2026 exam for us, and also that will induce a preparation method inside you, how to prepare for physics and how to individually prepare for different chapters and topics. As I always say, different chapters and different topics have different tastes of asking the questions being asked in the exam. All right. So let us start today. Today I'm here in front of you with a topic which is average values and instantaneous values. Average values and instantaneous values. This is not a topic which is only restricted to the kinematics or motion. All right. So basically, when we talk about average value or instantaneous values in physics for different physical quantities, this topic of discussion will almost come in each and every chapter of our syllabus. All right. So from the fundamental, what is the difference between the two? What are the correct methods to find out the average value and instantaneous values of different physical quantities? Today we are going to learn that. Yesterday's class was majorly focused on techniques of solving different types of problems. Today's interaction is going to be a bit more informative. Means I'm going to give you a lot of information. A lot of information you have to carry along with you for your entire journey of NEET preparation, because as I said, it is not restricted only to kinematics or motion. In fact, it will keep coming in different chapters for us. All right. So let us start the discussion. Yeah. So now, first of all, I'll introduce the concept of average and instantaneous values. So average value is defined in a particular duration, defined as the name average suggests. It is defined for a given duration or interval. For a given duration or interval. Whereas, and it is basically given by, it is substitution based. It is substitution based. Means if we are going to find out the average value of any physical quantity over a given interval or over a given duration, we are going to use the substitution techniques or technique of mathematics. I'll give you a few examples. You'll understand it better. So substitution based. Okay. This as a rule you need to remember. Similarly, if I talk about the instantaneous values, instantaneous value, it is defined at a moment. It is defined at a moment or an instant. And if it is defined at a moment or an instant, then definitely how to calculate the instantaneous value of any physical quantity, that is differentiation based. Differentiation based. So indirectly, I'm trying to say this, that if the examiner is asking you the average value, you can think about the substitution in the question or a numerical problem. And if the examiner is talking about the instantaneous value, then you should definitely think about the differentiation too. All right. For example, example number 1. Suppose I start with average velocity only. Average velocity. So if I talk about average velocity, the average velocity V average vector is given by, how do we define the velocity here? How do we define velocity? Displacement by time, or you can say change in position with respect to time, with respect to its surroundings. All right. So average velocity will be given by delta x vector by delta t. You can also say that differentiation is used for small changes. So instantaneous changes, small changes. Small changes are given by differentiation. Okay. Average defined for a bigger interval or defined for a duration. So you have to deal with big changes, delta. All right. And delta, big change, is basically substitution based. I repeat, instantaneous values are defined for an instant, for a moment. So we are dealing with small change or big change? Small changes. And if we are dealing with small changes, we have to make use of differentiation. Average values are defined within a given interval or for a given duration. So we consider that duration relatively bigger. And hence we have to deal with big changes. If we have to deal with big changes, who will help us? Delta. Delta will generally refer to big change. I'll write it for you here, that delta generally refers to big change. Big change. All right. And D generally refers to small change. In general, that's valid. In our discussion, we are going to understand it this way, that whenever I'm writing delta, I'm trying to refer to the big changes. And whenever I'm trying to write D, dy by dx, then I'm trying to refer the small changes. All right. Yeah. So that can be further written as delta means big change, which is substitution based. So you should be writing it as x final vector minus x initial vector by t final minus t initial. T final minus t initial. Whereas if they are asking you instantaneous velocity, then we can write this instantaneous velocity v subscript instantaneous. That will be, for instantaneous things, we have to deal with small changes. And for dealing with small changes, which mathematical tool will come into the picture? Yes, differentiation. So you should be writing it as dx vector by dt. Dx vector by dt. So what you can see, average values are based on substitution, whereas instantaneous values are based on differentiation. All right. But I'm repeating it again, that this thing is not only restricted to the kinematics, but you will keep finding this thing again and again in each and every chapter almost for your syllabus. For example, similarly, in next few minutes, we will also talk about the acceleration, instantaneous acceleration and average acceleration. But before that, let me take you towards the next unit, that is laws of motion. There you can define by Newton's second law, if I have to write average force, then we know that according to Newton's second law, time rate of change of linear momentum will give you the external force. So average force, F average, is given by delta P vector by delta T, which means you can write it as P final vector minus P initial vector by T final minus T initial. Again, substitution based means you have to put the initial time in momentum expression, you have to substitute the final time in the momentum expression. You will do final minus initial by final minus initial time instants. So what you are doing, basically you are substituting the values. Okay. Whereas if they are asking you instantaneous force, then this instantaneous force will be given by dp vector by dt. So what you are going to do here is differentiation. All right. Average values are based on substitution. Instantaneous values are based on differentiation. And this is not only limited or restricted to kinematics. It will keep coming in each and every chapter almost. What is the next chapter after laws of motion in our syllabus? Which is the next unit according to NCERT? Yes, that is work energy power. So in work energy power, if I go and if I talk about here, if I talk about average power, so I will say that average power, P average, is given by, how do we define power, dear? We define it as rate of doing work is called power, or rate of dissipation of energy is called power. So here we can write delta Ke by delta T, or net work done, because by work energy theorem, net work done is equal to change in kinetic energy, and here it is T total, which can also be further written as Ke final minus Ke initial by T final minus T initial. So what did you do again? You did final minus initial, final minus initial. This is basically substitution based. And if we talk about instantaneous power, the instantaneous power is given by, again, instantaneous things are basically defined for small duration, and those are differentiation based. So that will be equal to dke by dt, and it is very important, or dw by dt. This is a very important expression for NEET preparation. This is a very important expression. You'll find majority of NEET PYQs related to power dependent on that, and in our practice going ahead also, we will emphasize a lot, not today on this particular expression, but at the right time. Today, our total focus is on average and instantaneous values of different parameters in different topics and different chapters. Okay, right. Very nice. I can see that on the comments, in the comment section, many friends are answering that along with me. Right. I hope that's clear. If you want to take a screenshot, you can. After the session, one day later, we will also upload the notes of these lectures along with in the description along with the live sessions. Okay. Right. Now, so now let us come back to our topic of discussion. We started our journey yesterday with kinematics. So now we will emphasize on average and instantaneous values for the parameters in kinematics, that is velocity as well as acceleration. Okay, velocity we have seen it. Once again, we will revise it. But remember, I have given you few examples just to tell you that whatever you will learn today, that will keep on helping you, that will keep on benefiting you throughout your journey. Okay, now let us talk about average and instantaneous values. Before I talk about velocity and acceleration, first of all, we will try to emphasize on language. Let us emphasize on language. Means every time we are facing the problem in physics, the problem is not because of the physics, and the problem is sometimes not even because of the maths involved in the question, but the problem lies in the language of the question. What examiner is asking and what you are interpreting, that obviously must be same, right? So I'm going to write few things in front of you to understand the difference in the language of the question being asked. Okay, so if they say, suppose they are telling that x position x of a particle, is given by 2t square minus 3t plus 4. Okay, 2t square minus 3t plus 4. And they are asking you few things here. First thing, what they are asking you is, they are asking you average velocity in 3 seconds. Average velocity in 3 seconds. So how you are going to get average velocity in 3 seconds? 3 seconds refers to the first 3 seconds, means from t equal to 0 to t equal to 3. So how do we define the average velocity? We define the average velocity as delta x by delta t. So that will be x final minus x initial by t final minus t initial. And as you can see, as I said, that it is average value. Average value is substitution based. So here in the expression of position, we are going to substitute t final, then we are going to substitute t initial, and then we will take the difference. For example, t final is 3 and t initial is 0. Average velocity in t equal to 3 seconds means this refers to what? This refers to t initial is 0 and t final is equal to 3 seconds. Alright, so let us substitute the value. X final means in this expression we have to substitute t equal to 3. So what we will get? 2 into 3 square minus 3 into 3 plus 4. Similarly, minus, when I will substitute the initial one, in order to get xi, I have to substitute ti. So that will be 2 into 0 square minus 3 into 0 plus 4. And in the denominator, we will get t, we will substitute t final minus t initial. So that is t final is 3 minus t initial is 0. I hope you understood. Further calculation is easy, you can also do that. But my purpose of telling you this is that average value is defined for a duration and average values are always calculated by substitution if the expression is given. But what if they ask in the same question a very simple problem, but now they ask the instantaneous value. Instantaneous value. So here if they ask instantaneous velocity at t equal to 3 seconds. Instantaneous velocity at t equal to 3 seconds. Or let me write velocity at t equal to 3 seconds. Velocity at t equal to 3 seconds. So at t equal to 3 seconds. At means instantaneous value. Okay. So at t equal to 3 seconds, instantaneous value. Instantaneous values are defined for a moment and they are always given by differentiation based. So the V average value, V instantaneous value will be given by dx by dt differentiation. So that will be d by dt of 2t square minus 3t plus 4. D by dt of 2t square minus 3t plus 4. So if you are going to differentiate that, what you will get here is 4t minus 3, 4t minus c, this will be 4t minus 3 plus 0, and here we need to substitute t equals to 3. So that will be naturally 4 into 3 minus 3. You can get your final answer. Okay, that's easy. But here we are trying to emphasize a bit more on the language. Now what other language can be used for us? Now this is a tricky one. They ask sometimes, this is a tricky part on which I wanted to emphasize actually. Velocity in t equal to 3 seconds. Velocity in t equal to 3 seconds. Similar problems for us. They sometimes ask on the basis of Faraday's law. Faraday's law in electromagnetic induction. Similar problem is they ask that EMF value, EMF induced at t equals to 3, t equal to 5 seconds, and EMF induced in t equal to 5 seconds. Did you understand the difference in the language? One time they are saying at t equal to something. Another time they are saying in t equal to something. See, I'm going very slow. Just trying to improve your English or language a bit before improving the physics. Okay. So understand, EMF induced at t equal to this means they are asking you the instantaneous value. But EMF induced in t equal to 5 seconds means you have to consider a time duration. At means they are asking you instantaneous. Instantaneous. Okay. And in means they are asking you, the average value in fifth second. Average value in fifth second. That is fifth second. Fifth second can be a moment, dear, and fifth second can also be a duration. I repeat my words. T equal to 5, fifth second can serve as a moment also, and fifth second can serve as a duration also, as an interval also. How is it possible, sir? See, you will agree with this. Average value in fifth second. Fifth second I am considering it as an interval that starts from Ti is equal to 4 seconds and Tf is equal to 5 seconds. That is from t equal to 4 to t equal to 5 seconds. Alright. Fifth second can serve as a moment as well as fifth second can serve as a duration. When you say first second actually refers from 0 to 1. Second refers from 1 to 2. Third second refers from t equal to 2 to t equal to 3. So isn't it serving as an interval? Yes. So sir, what to take t equal to 5 as a moment or as a duration? That depends on the English of the problem. That depends on the language of the problem. If they say that, suppose they can ask you anything, they can ask you force. If they are mentioning average force, substitution based. If they are mentioning instantaneous force, differentiation based. But if they are just saying tell me the force, then the tricky state arises. We need to understand this. I repeat, I think we got disconnected. Let me know in the comment section, are we still connected? Are we still connected, guys? Just a moment, let me rectify the connectivity. I think everything is working fine. Okay. So, yeah, what I was telling you is, Sri Ram, you have mentioned that the fifth second average value would refer to 0 to 5. No. Average value for 0 to 5 seconds, average value for 5 seconds and average value of fifth second mean different. I repeat for everyone, listen to me very, very carefully. Average value for 5 seconds and average value for fifth second totally are different stories. So once again, if they mentioned tell me the average value, you have to use the substitution. If they mention tell me the instantaneous value, you have to use the differentiation. But the tricky situation arises if they don't tell you that what you want to find, what you need to find, whether it is average value or instantaneous value. They just say tell me this parameter, tell me this physical quantity at t equal to something or in t equal to something. If they say at t equal to 5 seconds, means 5 seconds is serving as an instant. In t equal to 5 seconds or in fifth second, I'm not saying in first 5 seconds. No, I'm saying in t equal to 5 means, or let me replace it as at fifth second or in fifth second. Now I think it will make more sense for you. Okay, so instantaneous value, at means you are talking about that instant, in means you are talking about that t equal to 5 second as a duration that varies from 4 to 5, 4 to 5. All right. So if they say velocity in t equal to 3 seconds or velocity in third second, velocity in third second. So I will say better to write it as x at t equal to 3, x means x final, minus x at t equal to 2, because this third second will vary from 2 to 3. This third second will vary from t equals to 2 to t equals to 3. Now I think the language will make more sense for you. So x at t equal to 3 minus x at t equal to 2 by 3 minus 2. This way you can do that. This point, this tricky situation is very, very less important if we only talk about the kinematics or motion. But this will become significant importance when we talk about the other units and other formula, other expressions like this. So I hope a bit about the language. At right time, I'll keep on focusing on these things, but a bit about the language we have emphasized and you have understood the difference between the two. All right. So a quick recap before we move forward. First of all, we have understood today what is the difference between average value and instantaneous value. Average value is defined for a duration, and we deal with big changes. So it is given by substitution. Instantaneous values are defined for a moment. We have to deal with small changes and hence we use the differentiation. All right. These you will find in almost every chapter and topic of your NEET syllabus. Then we have talked about a bit tricky situation because of the language that arises when they say at a moment or they say in a duration. So at a moment means instantaneous, within a duration means you have to talk about the average value. Do understand if I mention any particular second, that second may serve as a moment, that second may serve as a duration, that will entirely be decided by the language. At means they will refer to the instantaneous, within that duration means naturally you have to find out the average value. All right. Hopefully you can do all such calculations here and get the final answers. We are not spending good time with the calculations here. So I think if you want, you can take a screenshot, then we will move ahead. You know, NEET is a national level exam. So for a national level exam, it is also required to focus much on the language of the problems, interpretation. Okay. So now we have to talk about the average and instantaneous value. I'll quickly tell you that because once we have already discussed recently, average velocity, if I talk about average velocity, the average velocity will be given by big change. It is defined for a duration. So that is delta x vector by delta t. This change in position vectors, this change in position vector is also called as net displacement. So that is net displacement by total time. Net displacement by total time. So that can be written as x final vector minus x initial vector by t final minus t initial. T final minus t initial. And if I particularly talk about the instantaneous value, so I will say instantaneous velocity vector will be given by small changes you have to deal with. So it is dx by dt differentiation. Okay. One more thing here, a very common theoretical point, although we are not going to emphasize on that today, but since we are studying the theoretical part, I'm sharing that with you. So distance is always greater than equal to displacement. Distance is always greater than equal to displacement. When this equality will be satisfied, sir, when this equality will be satisfied, this equality will be satisfied only for unidirectional motion. Only for unidirectional motion. Otherwise, distance will be always bigger, right? Only for unidirectional motion. Unidirectional motion means unidirectional motion means moving in a particular direction, or you can say moving along a straight line without turning. Unidirectional means moving in a particular direction, or you can also say that for our understanding, moving in a straight line but without turning. Because if a body even moves in a straight line and turns back, then distance will be something else, displacement will be smaller than that. All right. So this is the situation. And I would say magnitude of displacement, as we can't directly compare a scalar and a vector quantity. So we are comparing the scalar quantity to the magnitude of a vector quantity. All right. Dividing by total time. If I divide by t total, so what I will be getting is that total distance by total time, that will be the average speed. Average speed is always greater than equal to, we already know when the equality is satisfied for unidirectional motion, it is greater than or equal to magnitude of average velocity. Magnitude of average velocity. Is that clear? So yeah, so that is all about the average and instantaneous velocity. We are right now not emphasizing on the units and dimensions and the other properties, because today we have to get a strong command on finding the average and instantaneous values of different parameters that may be asked to us from different topics and chapters. So any doubt to anyone? You can just post all of your doubts in the comment section. I'll keep answering them. In comparison to yesterday, today I'm going a bit slow for you, so that, you know, we will keep listening to the same things again and again, and then that will be fitted in your memory. So next time, whenever I'm teaching you any average or instantaneous value of any physical quantity, I'm sure you'll be able to directly tell me, sir, you have to use differentiation or you have to use substitution. Average values, substitution based. Okay, is that clear? No doubts? Very nice. So now let me take you a bit ahead towards the same average and instantaneous values, but this time of acceleration. Acceleration, how? Average acceleration, if I talk about, so average acceleration will be given by, again sir, average value. Average value means we are talking about a big interval relatively, which means we have to talk about substitution based things. So delta v vector by delta t. Everyone knows the meaning of acceleration, or how the acceleration is defined. Acceleration is the time rate of change of velocity, or rate of change of velocity vector with time. Okay. So that is basically v final vector minus v initial vector by t final minus t initial. Remember guys, we can never talk about the acceleration directly from position. First of all, we have to cross the way through velocity. Means I'll write that also for you. I'm saying the position vector, x vector, position vector, okay, x vector, and velocity vector, v vector. Velocity is anyways by default a vector only. And if we talk about a vector, that's acceleration. All right. If you have to go like in this direction, if you have to go in this direction, then you will be needing the you need to differentiate that. Differentiation. And if acceleration is given and you want to move in the reverse direction, if acceleration is given and you want to move in the reverse direction, then definitely you have to use integration. Okay. We all know that differentiation and integration are opposite processes. That too we know, sir, that differentiation and integration are opposite processes. Now, what's happening over there is what I just said, that whenever you have to comment about the acceleration, directly jumping from position will not be fine. Okay. You have to go through the velocity, whether you go from position to acceleration or you go from acceleration to position. Further on these things, we will also emphasize tomorrow. Our next interaction. In our next interaction, you'll enjoy it a lot, and all the doubts related to the graphs. I know you people are a lot struggling, and generally a lot of candidates struggle in the graphs of kinematics. And our intent for this bridge course is very much clear. I would guide you for the graphs of kinematics in our upcoming interaction, but our knowledge and our dealing will not be restricted only till the kinematics graphs. We will also understand how today's fundamentals are connected to the graphs and how those graphical skills which I am going to teach you for kinematics are also and always applicable for different chapters and topics of syllabus. Okay, a NEET goal. All right. So what I'm telling you here is what I want you to keep it in mind for next few minutes is if position is given and acceleration is required, or acceleration is given and position is required, the pathway must cross that must be going through the discussion of velocity. All right. How it is important and why so many times I am saying that to you, you'll realize it very soon. Okay. I'm after this discussion, I'm going to take few interesting examples. So instantaneous acceleration. How do we define the instantaneous acceleration? It is equal to dv vector by dt. dv vector by dt. So instantaneous values are differentiation based. Average values are substitution based. Is that clear? Right? And just remember that tip which I have just given to you. All right. Let me take few examples. So one example is, I'm giving you a very basic example here. I'm starting with this, that suppose position vector or position x is given with respect to time as 2t square minus 3t plus 4. I think it is similar to the expression which I have just taken. And if examiner is asking you that determine, so directly if they ask the average and instantaneous velocity, you know what to do. Okay, directly you can substitute and directly you can differentiate. But if they ask determine the first part, average acceleration in first 5 seconds, average acceleration in first 5 seconds, and second part they are asking you instantaneous acceleration at t equals to say 4 seconds. All right. So previously I have given you an example in which I have taken the same equation 2t square minus 3t plus 4, the position with respect to time, position, how it varies with time, that is given to you. And what I have asked you previously is velocity everywhere. So you can directly differentiate or you can directly substitute, because position's next step is velocity only. So you can directly differentiate or you can directly substitute because it is the next step. But whenever it is the case of acceleration from position to acceleration, there are 2 steps. So first of all, you need to entertain the velocity also, the expression of velocity. All right. So how do we do that? We will say here, first of all, we will find out the velocity. Which velocity we will find, sir? We will find the instantaneous velocity or we will find the average velocity? We will find none of them. We will find the general expression of velocity. This velocity is not the average value. This velocity is basically the general expression at any time t, kind of instantaneous value. It's like the instantaneous value, but not at a defined instant. It is kind of an instantaneous value which we look for, but not at a well-defined instant, but rather in general, in terms of time. So we will write it as dx vector by dt. So we can easily differentiate that. So that will be equal to 4t minus 3 into 1 plus 0. So that is nothing but 4t minus 3. This implies what we got is v vector is equal to 4t minus 3. All right. This is the v expression for v, what we have got. Fine. Now they are asking you the first part, average acceleration in first 5 seconds. So average acceleration in first 5 seconds means that will be equal to v final. So basically average values are substitution based, that is delta v by delta t. So I'll be writing it as v final minus v initial by t final minus t initial. Expression or coordinates can be taken as the vector here. So we will say V final vector minus V initial vector. See, V final, T final is basically, you are talking about first 5 seconds. First 5 seconds means T final is 5 and T initial is 0. So in the expression of velocity, put the value of T as 5. So 4 into 5 minus 3 minus 4 into 0 minus 3. 4 into 0 minus 3. You see? And that will be 5 minus 0. 5 minus 0. So if you see that carefully, I'll just expand it. It will be, you can see this 3 and 3 being constant will be anyways cancelled out. 4 into 0 is 0. That's 4 into 5 by 5. So it is 4 meter per second square. That is the average value. Not only that, we can also get it as, see the second part, they are asking you the instantaneous acceleration. So instantaneous acceleration is dv vector by dt. dv vector by dt means instantaneous values are differentiation based. So if you are going to use that as a differentiation based, you will get it as 4 into, see, it's differentiation, 4 into 1 minus 0. So that is also 4 meter per second square. Anyways, if instantaneous value, you know, that came out to be time independent. And if you see, the moment you differentiated the velocity, there was no time to be substituted at t equal to 4. The moment you differentiated it, after that you wanted to substitute t as 4. But is there any t available in the expression? No. So as a result, you will say that here this term is coming as a constant. This term is coming as a constant, and whenever the acceleration is constant, yesterday also we have learned that this is called as uniformly accelerated motion. Uniformly accelerated motion. All right. I hope the logic is clear to you. What twist I have produced in this problem is, generally in the exams and generally during your practice, you always practice while talking, you know, position vector is given and velocity is required. Velocity vector is given and acceleration is required. But what if position vector is given and they are asking you the comparison of average and instantaneous accelerations, double time differentiation. So what we have learned here is, first of all, always your way will cross the expression of velocity. Average values are given by substitution, no differentiation. Instantaneous values are given by differentiation, no substitution. But average acceleration and instantaneous acceleration are based on substitution and differentiation of velocity expression, which was not directly given. What was given is position expression. First of all, always differentiate to get the general expression of velocity. General expression of velocity, because it's 2 times differentiation required. So first time differentiation is must. Second time maybe substitution is required if average is asked. Maybe differentiation is required if instantaneous is asked. But first time differentiation is must. Is that clear? Did you understand the essence and beauty of this problem? Why we spend so much time with this? Yeah. Instantaneous velocity. Sheikh Shaheen is asking, sir, please explain some more examples. Okay, I'll take. The entire lecture is based on a lot of examples. As I said yesterday, it was, you know, simplifying mathematical techniques for you. Some tips and tricks, Galileo's formula we discussed. Today's class is too much informative. But this information is going to be in your head. It should be in your head for our entire journey of NEET preparation. All right. Now, once again, I'm telling you, instantaneous values are defined for a moment, for an instant, differentiation based. Average values are defined for a duration, substitution based. The entire lecture, I'll keep repeating the same thing here. Okay, if you want, you can take the screenshot of that. Few more examples we will take. All right. Integration, Yashaswini, integration and differentiation methods, bacha, we will deal in different session. You may also find that lectures already uploaded on the same platform. Don't worry about it. Just spend some time, scroll some lectures, you will find the content of differentiation and integration also. Very soon at right time, we will also emphasize on those skills. But as I'm assuming that all the students who are connected here, our goal is to target for NEET 2026. That is the upcoming year NEET exam, which means the basic differentiation and integration, I'm assuming that, you people know. Still, don't worry. Every time there will be a differentiation and integration thing required, I'll simply explain it to you. Okay? Any other doubts, dear? Yeah. Let's go. First step for us. Now we will talk, see, we have understood the average and instantaneous values general method, but our speciality is that apart from general method, we also keep talking about the time saving methods. So first of all, we will talk about the average velocity in uniformly accelerated motion. Average velocity in uniformly accelerated motion. So what is uniformly accelerated motion? Uniformly accelerated motion means my acceleration is non-zero and acceleration is constant. Yesterday also we were talking about it, that acceleration constant, for a vector to be constant, its magnitude is also constant and its direction is also constant. For any vector to be constant, its magnitude mod A is also constant, and cap means unit vector, direction, that is also constant. All right. Now, how to find out the average velocity in uniformly accelerated motion? So the tip is that V average is defined as, but this is only defined for uniformly accelerated, means the acceleration must be constant. So that is defined as u vector plus v vector by 2. U vector plus v vector by 2 means I will say average velocity is given by the average of the initial and final velocities. What is the language? In exam, they might not ask you the 4 options in terms of expressions, but they may ask you the 4 options in terms of language. So you need to have a good command on the language also. The language is average velocity is given by the average of initial and final velocities. Average velocity is given by the average of initial and final velocities, but this is only applicable for uniformly accelerated motion. Only applicable for uniformly accelerated motion. All right. Subsequently, or as a consequently, what you can say, like if you agree that this is the average velocity, it is only for uniformly accelerated motion. But average velocity is net displacement by total time. Net displacement by total time. It is always valid. By this is the general definition, no? It is always valid. This implies from here the net displacement can also be written as average velocity into time. Average velocity into time. So that can be written as u vector plus v vector by 2, u vector plus v vector by 2 into t. This is another equation which we will be using in our journey of kinematics based problems. This is one of the, again, one of the important equations. Why this equation is important? Because if you talk about the 3 general equations, standard equation, v equal to u plus at, s equal to ut plus half at square, and v square is equal to u square plus 2as. All 3 equations of uniformly accelerated motion are involving a acceleration. But examiner is very smart. Sometimes examiner will tell you that acceleration is constant, but how much they won't tell you. So this is another equation which can be used smartly in uniformly accelerated motion, provided we are sure that the motion is uniformly accelerated, that acceleration is constant. But how much, sir? What is the value of that constant acceleration? That is not clear to us. Understood? The first equation is v equal to u plus at. Second is s equal to ut plus half at square. Third one is v square is equal to u square plus 2as. Another equation which we talk about sometimes is distance traveled in nth second, u plus a by 2 2n minus 1. So all these standard equations involve a. Interesting part with this equation is, what is the interesting part? That it is valid for uniformly accelerated motion despite having no information of acceleration. Information is only that acceleration is constant, but how much? We don't have that value in our information. All right. Okay. Now, so how do we get that? If you are having this doubt, how do we get that? That feeling must also be entertained here. See that Vnet vector is defined as Snet vector by Tnet, like that. So you can write it as ut plus half at square. I'm not writing vector again and again, but all of you know that these are the vector equations by t. So what you are going to get is u plus at, single t will be cancelled here, by 2. So what you can get is 2u plus at by 2. So you can write it as u plus, single u I am isolating, u plus at by 2. That simply means finally what you can write here is, this u is u, but u plus at is v by 2. So that's how you are getting the average velocity expression. All right. Today only I am going to tell you a very important problem for NEET 2026. That is our upcoming goal. And where, if you know these techniques, how you can solve the questions very, very easily. But in the absence of these techniques, it may be a time consuming process. Okay. So we will look for it very soon. All right. Any doubt on the screen? Any doubt? You can tell me in the comment section. In today's class, I am also trying to tune your mind in such a way that whenever you study a particular topic of physics, you don't only study or mug up, one formula, two formula. You have to understand each and every dimension of that, topic. Is that clear? No doubts? All right. Very nice. Smart people. No doubts. Okay. Now, here, me do that for you. Few examples. Okay. Where do we use that technique? For example, first is, suppose examiner is telling you that there is a particle at t equals to 0. This particle is moving with 2 meter per second and its acceleration is given as 5 meter per second square. I'm not writing it a equal to this because by the units you can easily judge which physical quantity it is. So 2 meter per second is the initial velocity, 5 meter per second square is its acceleration, and here at t equal to 5 seconds it has reached somewhere, and you have to tell me the displacement covered, the final velocity, the average velocity, everything. Displacement covered, final velocity, average velocity, everything. So let me do that for you. This is the first example. So first of all, I will say what is the velocity, final velocity. So with a rate of 5 meter per second square, it is in supportive direction to the motion. With a rate of 5 meter per second square in 5 seconds, how much will be the increment? Can I say 80, 5 into 5, 25 meter per second. So initial velocity is 2 meter per second. You have gained the velocity by 25 meter per second. What will be the final velocity? Yes, 27 meter per second will be the final velocity. Okay. Then if they are asking you the average velocity, so average velocity will be here, from here to here. Your average velocity will be equal to u vector plus v vector by 2. So 2 plus 27 by 2. So that is equal to 29 by 2. And if they are asking you the displacement covered, then you can see I'm not using those s equal to ut plus half at square and all those equations. Can we do that also, sir? Yes, we can do. But do we want to do it right now? No. We are trying to learn. We are trying to understand how the average value of velocity or finding this average velocity is going to be very helpful for us. All right. So net displacement will be equal to average velocity into time. Average velocity into time. What is the average velocity? 29 by 2. And what is the time you are having here? 5. Like this. So obviously you can calculate this further in meters. Is that understood? So yeah, you people are answering it very fast. I'm very happy. Right. Very nice. Very nice. So 29 by 2, and this is the another one, right? Similarly, if I take another example for you, that suppose at t equals to 0, object is moving with 6 meter per second. Okay. And the retardation is 3 meter, or you can say 2 meter per second square. This is the retardation at 2 meter per second square, and they are asking you the final velocity at t equals to 5 seconds. So at t equal to 5 seconds, now if you see that in this case, what is happening? In this case, what is happening here? That acceleration and velocity this time are not supportive. Last time acceleration and velocity were supportive, but this time they are not supportive. So there may be a chance that you may have the velocity in this direction. There may be a chance you will have the final velocity in this direction. We can find out easily. How? Our convention is very simple. Forward positive and backward negative. So here I'll find out the value of v, as v vector will be equal to u vector plus a vector into t. U vector plus a vector into t. See, that equation is a vector equation. Substitute everything with plus minus sign. Initial velocity is plus 6 because it was forward. Acceleration is minus 2 and the time is 5 seconds. So what you got is 6 minus 10. 6 minus 10 is minus 4 meter per second. Minus 4 meter per second. What this minus is denoting? This minus is denoting towards left. Towards the negative x-axis. So I will say this will not be the velocity here. This will be the velocity, and this velocity is given by 4 meter per second. But remember, it is in left, means negative. So from here to, so basically the journey would have been, if you try to understand how the particle would have moved, the particle would have moved somewhat like this. The particle would have moved somewhat like this, and then after stopping somewhere here, the particle might have turned somewhere here. All right, this would have been the journey. Somewhere here, the instantaneous velocity of the particle would be 0. Means I'm an object, I'm moving in the forward direction, someone is pulling me behind. So I'm moving in the forward direction, someone is pulling me behind. What will happen to me? I'll slow down, somewhere I'll stop, then I'll keep moving in the opposite direction. So that is happening here. Okay. So in this journey from here to here, I will say your average velocity is defined as u vector plus v vector by 2. So that can be written as, what is initial velocity? Plus 6. What is final velocity? It is minus 4 by 2. 6 minus 4 is 2, 2 by 2 is 1. So that is 1 meter per second. And if they are asking you net displacement, which is not equal to total distance, it will be less than the total distance, because it's not a unidirectional motion. It is a straight line motion, but it is a straight line motion with turning. Means distance will be A to B plus B to C, but displacement will be only AC. Distance will be A to B plus B to C, but displacement will be only smaller part, AC. Right? So net displacement or d total will be equal to average velocity into total time. So average velocity is what? Average velocity is 1 meter per second. It's positive, and total time from here to here is 5. So it is plus 5 meter. Plus 5 means, positive means it is actually ahead. It is actually in the right side. All right. Yes. Very nice. I really love it. Whenever I'm looking at the screen, a lot of people are answering before me. It's very nice. So, I think I need not to ask you whether it is understood or not. I hope I can see that it is clearly understood for all of you. Very nice, guys. All right. If you want, you can take a screenshot just as an application. just to understand the application of this discussion. It is also a beautiful technique for today. In the absence of this technique, the same crucial problems may take a lot of time and energy of yours in the exam. But if you use these techniques, some big problems will be easily simplified. We will see that very soon. Okay, chalo. Sir, please explain this model once again. Okay, I'll explain that. What is the model? So the applications I am not explaining again. Application I'll directly explain once again in some other examples. Okay, because we are having a lot of examples. But let me tell you the technique. It will be a revision for everyone else. The technique is average velocity can be given by the average of the velocities. Average velocity can be given by the average of initial and final velocities, but this is valid only for uniformly accelerated motion. But average velocity is total displacement by total time. It is valid every time. Is that clear? All right. Chaliye. Let us move on another case, that is, so average velocity we have talked about, right? But now our discussion will be with the average speed. Average speed. There are different cases of finding the average speed. Okay. So what is the definition of average speed? Before we go ahead, we need to understand the definition. The definition of average speed is defined as total distance traveled by total time taken. D total by T total. Total distance traveled by total time taken. For example, case 1, suppose the most basic case I am talking about. Suppose examiner is dealing with 3 intervals and they are saying 3 intervals for the motion of the particle, and they are saying a body covers d1 distance in t1 time, then d2 distance in t2 time, and then d3 distance in t3 time. Tell me the average speed. So I will say here average speed will be equal to, it is simply d total by t total. You know, you have been doing this since your childhood. So it's very easy. What is d total, sir? d1 plus d2 plus d3. And what is t total, sir? t1 plus t2 plus t3. All right. Now, case 2. Let me modify it further. If they say that for the first interval, body travels with v1 speed for a t1 time, then the body travels with v2 speed for a t2 time, then the body travels with v3 speed for a t3 time. In that case, how to write down the average speed? Remember, we are talking about distances. We are talking about path lengths. During the calculation of speed or distance, we need not to look for the direction. Displacement and velocities are the vectors. For their discussion, we have to understand in which direction the body is moving, whether the body is turning or not turning. All those things must be coming into your consideration when you are dealing with the vectors. But when you are dealing with the scalars, you need not to worry about that. Okay. Average speed will be given by, again, d total by t total. Now, the distances, the time are known. The time are known, t1 plus t2 plus t3, but the 3 distances are not known. So how to write down the distance here? We know for any interval, again I'll be using the same formula here. For any interval, distance will be written as speed into t. Okay? Distance will be written as speed into time. So what you can write here is, first interval distance as v1 t1, second interval distance as v2 t2, third interval distance as v3 t3. Is it fine? All right. Let's talk about another one. Case 3. For first interval, it's again modified version. For first interval, particle travels with distance d1. Particle covers a distance d1 with v1 speed. Then particle covers a distance d2 with v2 speed. Then particle covers a distance d3 with v3 speed. And then they are asking you, tell me the average speed. So I will say here average speed will be given by, this time what is known for us? Distances are known for us, d1 plus d2 plus d3, d1 plus d2 plus d3. And what is not known for us? What is not known for us? The time are not known for us. But the time instants for any interval can be written as distance by speed. See, speed is equal to distance upon time. Distance is equal to speed into time. Time is equal to distance upon speed. So distance upon speed means here it will become d1 by v1 plus the next time interval is d2 by v2 plus the next time interval will be d3 by v3. Is that clear? Very easy, no? See, here it is directly total distance traveled by total time taken. Here in the second case, the blue colored case, time durations were given. So you just got the total time. But for calculation of distance, we again use the same general formula. Similarly, in case 3, these are basic cases. The first one was straightforward, very easy. In the case 3, total distances are given to you. For total time calculation, we must be entertaining the individual time durations. We must be calculating the individual times first. All right. Now, let me mix them all. How the examiner will make the question tough. Multi-concept approach when we say that, or multi-model approach. That is, you need to understand. Approach means you need to understand that a particular question has been formed by combining multiple cases or multiple concepts. So let me introduce that for you. Focus on the language, because the diagrams I am drawing, examiner will not draw for you. We have to draw it for ourselves after understanding the language. So examiner says a body travels d1 distance in t1 time, then travels with the speed v2 for t2 time, and then covers a distance d3 with v3 speed. I repeat, a body covers d1 distance in t1 time, then travels with v2 speed for a t2 time, and then covers a distance d3 with the speed v3. Language, boss, language. V average will be given by, very easy sir, something plus something plus something, something plus something plus something. Now, whatever distances you can see directly, put it in the numerator. Whatever time in durations you can see directly, put it in the denominator. So in the numerator, d1 I can see, d3 I can see. In the denominator, t1 I can see, t2 I can see. The remaining things are not given as such, but we can easily find out. How? So we need the distance for this interval. So how we can get the distance for the second interval, intermediate interval? We can get it as v2 t2, v2 t2. And we also need the time for the third interval. So time is given by, see, distance is given by speed into time. Here time is given by distance by speed. Distance by speed is d3 by v3. Okay. So after understanding the language of the question, you can draw this type of diagram and you can then stick to the same formula that average speed is always given by total distance traveled by total time taken. All right. You can take the screenshot of this. All right. There are a lot of other special cases regarding the average speed also and average velocity also, and a lot of numerical problems we are going to discuss. Today's interaction, I have tried to deliver a lot of concepts. There are more shortcuts coming in our further journey of this bridge course for our core preparation for the NEET 2026. Okay. And definitely when you will be coming for the classroom programs also, then also we are going to deliver a lot of tips and tricks which are further the extended version of all the discussion. Hopefully you have understood whatever I have taught you. Now let me take another problem, because many of our friends were asking, I could see on the screen, that's some more example of that average value technique for velocity. More examples for these things, average value technique for velocity. And I also promised that for NEET 2026, I'll deliver a very important model for all of you. So let me show you the model now. The model is this, a very important model for NEET 2026. I will explain that in detail. With me, there are last few minutes. For the next 5 minutes, I want you to put your 100% focus, 100% attention on the screen. Okay. We will understand the situation. We have to evaluate 1-2 things. I'll tell you what are the different questions that could be asked. In final NEET exam, they will be asking you one thing. I'll tell you the 2-3 things that could be asked related to this situation. Okay. And then we will finally see that what is the general common way that any of your competitor in the NEET exam would probably try to do this problem. And then what is our way? Then what is our simple way, logical way of dealing with the same question or same crucial concept? All right. So can we start reading that together? Now, a car accelerates from rest at a constant rate alpha for some time. What is that time? Not given to you. After which it deaccelerates at a constant rate beta to come to rest. For what time? Again, not given to you. So which means initial velocity is 0, given to you. Final velocity is also 0, given to you for the entire duration. Acceleration alpha, retardation beta, they are not even similar. Time T1 and T2, suppose time for acceleration and time for retardation are T1 and T2, they are also not given, and obviously they will not be same also if the acceleration and retardation are different. Total time elapsed is T, that is given to you. Then you have to evaluate the maximum velocity reached and the total distance traveled. Maximum velocity and the total distance traveled. So whenever acceleration, velocity, time and displacement, whenever acceleration, velocity, time and distance or displacement are required or related in a particular problem, my favorite method is graphical method. And my favorite graph is the most versatile graph, that is VT graph. Why only VT, sir? Today I will explain it to you. But emphasizing more on the graph, that is the target of our upcoming session. So, dear, don't miss our day 3 session. In that, I will be teaching you all about the graphs of kinematics. Okay, introducing the graphical approach right now here only. So, situation is that I'll draw a VT graph here. Why only VT graph? Because velocity information is given to us. Velocity information is given or required to us. Similarly, acceleration, time and distance information are given or required to us. Okay, so we have to relate these informations. Now, the examiner says that a car accelerates from rest. So velocity is 0. It starts from here for some time and its constant acceleration is alpha given to you. So let me show that slope. In VT graph, if acceleration is constant, acceleration is given by slope. In VT graph, if acceleration is constant, then slope is constant. And this acceleration here is equal to plus alpha. This acceleration is plus alpha. And let me extend that a bit. And it attains a final velocity. It attains a maximum velocity here, I would say. I should not call it as final because final is again 0. And here then it deaccelerates. So acceleration will be minus beta. Acceleration or slope will be minus beta. And if I say that the time of acceleration from here to here is T1, suppose it is T1, and the time of retardation from here to here is T2, suppose. T1 and T2, time for acceleration, time for retardation, they were not given to us. Okay, and here the total time is T. This is given. Okay, so for the first portion of the journey, what we can do here is I can write the equation V equals to U plus AT. So I will say Vmax will be equal to 0 plus alpha into T1. So from here, T1 will be equal to Vmax by alpha. Similarly, for this portion, you can again write V equal to U plus AT. As you can see, the final velocity is 0. For this portion, the initial velocity is Vmax. but the acceleration is minus beta T2. From here you got beta T2 as Vmax. So T2 will be equal to Vmax by beta. T2 will be equal to Vmax by beta. All right. This is the situation. Now, can I say that here it is given in the problem that T1 plus T2 is equal to T, which means Vmax by alpha plus Vmax by beta is equal to T, which means Vmax, if you take common, that's 1 by alpha plus 1 by beta is equal to T. That means Vmax alpha plus beta by alpha beta is equal to T. That means the final velocity Vmax will be equal to alpha beta T by alpha plus beta. Alpha beta T by alpha plus beta. And if they are asking you the displacement or total distance covered, that will be area of this triangle. Area of the triangle. So what is that? Half base into height. So half into T into height is Vmax. Just substitute the value of Vmax here. So that's T by 2 and Vmax is alpha beta T by alpha plus beta. That means answer is alpha beta T square by twice of alpha plus beta. This is the situation. So that's a very important situation and question for the upcoming year NEET exam. I want you to remember the conclusions. But dear, was it the only method to solve this problem? No, sir. The first half is also uniform acceleration. The second half is also uniform retardation. Although the acceleration and retardations are not the same. Acceleration and retardation are not the same, but they are equal constant acceleration and retardation. So why not to talk about the average value technique? So see in one line or two line, how we can get smartly the solution of this problem or this situation. Okay, our way of doing that, I will say average velocity will be given by u vector plus v vector by 2. For the first portion, initial velocity is 0 and final velocity is Vmax. For the second portion, final velocity is 0 and initial velocity is Vmax. So ultimately, 1 will be 0, 1 will be Vmax by 2. Hence the answer is Vmax by 2. 1 will be 0 and 1 will be, hence the answer is Vmax by 2. So net displacement will be equal to average velocity into time. So that will be Vmax by 2 into T. See that carefully. That's what you got here. Okay, that's what you directly got here. So in this way, if you remember the logic that in uniformly accelerated motion, the average velocity is given by the average of the velocities, initial and final velocities, then definitely our big cases are going to get simplified. All right. So this was all from my side for today. I hope you have enjoyed the session. Do stay connected and share it with a lot of your friends. And you should be waiting for our upcoming day 3 session, in which I'm going to guide you all about the graphs of kinematics. So your fear for graph is definitely going to go away. All right. Till then, stay connected, take a small break. Then very soon you will be starting your chemistry session with Anirudh sir. All right. All the best. Bye-bye.